This is a video on functions from my Math 386 class. A function is a rule in which each x value corresponds to exactly one y value. For example, y equals 6 minus 2x. Every value of x corresponds to exactly one y value. And so we can say y is a function of x. Y equals x squared minus 2x. For the same argument, right, every value of x will produce exactly one y value. And so in this example, notice that y is a function of x. Now, let's take a look at this third equation here. Notice how I have x equals y squared. This is an example where y is not a function of x. And you might ask why. Because if I replace x with 1, now notice, if I take 1 squared, I get 1 back. And if I take negative 1 and square it, I also get 1 back. So notice that 1 corresponds to 1, and it also corresponds to negative 1. And so that's a problem. Every value of x must produce only one y value back. And so for this reason, y is not a function of x. Now, let's go back to this equation. Now, y equals 6 minus 2x. Okay? This says y is a function of x. Now, in function notation, I'm going to replace y with f of x. So again, this is read f of x, where f is the name of the function. And so I'm going to write f of x equals 6 minus 2x. Now, if I have y equals x squared minus 2x, instead of writing y, I can write, for example, g of x, where g is the name of the function. And I could say g of x is equal to x squared minus 2x. Now, this is what I want to do here. The directions say to evaluate each function for the given values. Now, in the first example, we have f of x equals 6 minus 2x. And in part A, I want f of 3. Now, this is the y value. That corresponds to x equal 3. Okay? And so f of 3 is, wherever I see an x, I'm going to replace it with 3. So I get 6 minus 2 times 3. But that's 6 minus 6, and you get 0 back. Let's take a look at B. What if I had f of negative 2? So this is 6 minus, wherever I see an x, I'm going to replace it with negative 2. But this is 6 plus 4. The answer is 10. Because negative 2 times negative 2 is positive 4. Positive 4 plus 6 is 10. Okay? on C. What if I had f of negative 12.7? Wherever I see an x, I'm going to plug in negative 12.7. But this is 6 plus, and then it turns out that, I think about it this way. 2 times 12 is 24. 2 times 0.7 is 1.4. So I'm going to get 2 times 12.7 as 25.4. And when I add those, I get 31.4. And then lastly, on D, f of 2/3. But this is 6 minus 2 times 2/3, right? Now, I can write this, if we don't mind, as 18 divided by 3. 18 divided by 3 is 6, right? And then 2 over 1 times 2 over 3 is 4/3. And when I subtract those, I get 14/3 for part D. Okay, so that's how we do example 1. Let's take a look at example 2. Suppose I had h of v equals 2v squared minus 3v plus 1. A, I want h of 0. Wherever I see a v, I'm going to replace it with 0. So I get 2 times 0 squared minus 3 times 0 plus 1. But this is 0 minus 0 plus 1. Answer is 1. B. What about h of negative 1? Now, when you start getting into negatives, what I would encourage you to do is, instead of writing a v, start off by replacing v with open parentheses. Because in those open parentheses, I'm going to put in a negative 1. And notice how I'm doing it in a different color. So it's, I hope, stands out, right? If I take negative 1 and square it, I get 1. And then negative 3 times negative 1 is positive 3. And then I'm going to add 1. And the correct answer here is 6, for example. And then let's take a look at C. Suppose I had h of 1/4. Now again, I can replace the v with open parentheses if you find that helpful, right? And in those open parentheses, I'm going to put 1/4 right here. So this is 2 times 1/16 minus 3 over 4 plus 1. Now, doesn't 2 go into 16 8 times, right? And so, therefore, h evaluated at 1/4 is, now I'm going to get 1/8 minus 3/4 plus 1. The LCD here is 8. So I'm going to write 1/8 minus 6/8 plus 8 over 8. And the correct answer here should be 3/8. Okay? And then D. Suppose I had h of negative 6.2. And I want to give you the idea here. Again, replace the v with open parentheses. So I have 2 times open parentheses squared minus 3 times open parentheses plus 1. And in those open parentheses, I'm going to put a negative 6.2 here and over here. Okay? Now, from here, I need to know what 6.2 times 6.2 is. And so you will need a calculator for this, right? So I'm going to take 6.2 times 6.2, and I get 38.44. So I get 2 times 38.44. Negative times a negative is a positive, and then I get 18.6. And then I add 1. And I'm going to take 38.44 and multiply by 2, and I'm going to get 76.88. And then 18.6 plus 1 is 19.6. And then when you add those up, I come up with 96.48 for part D. And that's how the second example works. Let's take a look at a third example. Suppose I give you the following. F of x equals 3x squared minus 6x. Okay? Now, in part A, I want f evaluated at 2a. So wherever I see an x, I'm going to replace it first with open parentheses, because inside these parentheses here, what you're evaluating f at is getting harder, right? And so I would encourage you to replace x with open parentheses first. And within those open parentheses, I'm going to replace, or I'm going to put 2a in its place, like so. Now, if I take 2a and square it, I get 4a squared, okay? And then 6 times 2a is minus 12a. And so when I'm all said and done, I get 12a squared minus 12a. On B, suppose I had f of a plus 2. Again, replace x with open parentheses. And in those open parentheses, I'm going to put in a plus 2. Right here and over here. Now, I'm going to come over here. Let's take a plus 2 and square it out. This would be like my side work. But that's a plus 2 times a plus 2. Okay? But that's a squared plus, if I multiply and add, I get 4a. And then I'm going to add 4. 2 times 2 is 4. So this is 3 times a squared plus 4a plus 4. And then if I distribute the 6 in, right, with that negative, I get minus 6a minus 12. But I have to distribute the 3 in, okay? And I get 3a squared plus 12a plus 12, right? Minus 6a minus 12. Now, notice, what happened to the 12s? Isn't 12 minus 12 0? And then if I take 12a and I subtract off 6a, I get 6a. And so my final answer is 3a squared plus 6a. Now, that's B. Now, let's erase this part, and we're going to go to C. Now, on C, I want to know what f of a plus 2 is. Now, let's go back. F of x is 3x squared minus 6x. I'm going to replace x with a. So I get 3a squared minus 6a. Now, this piece I'm going to put in parentheses to stress that that's f of a. Then all I have to do is add 2. So 3a squared minus 6a plus 2 is how we work part C. And then part D, what if I wanted f of negative a? Wherever I see an x, I'm going to put in open parentheses first, right? And then in those open parentheses, I'm going to put a negative a in there. But when I take a negative and square it, I get a positive. Okay? And so here I get 3a squared. A negative times a negative is a positive, so I'm going to add 6a back. And I'm done. Couple more. What if I give you this one? F of t equals negative 3. Now, this one's very interesting because no matter what I replace t with, my output will always be negative 3 the whole time, right? So here, if I wanted f of 4, it's not meant to be a trick question. F of 4 will be negative 3. B. If I want f of negative 3, it's negative 3. C. If I want f of b minus 2, I get negative 3 back. The output is the same. And then on D, if I want f of negative t, that is also negative 3. So notice I get the same thing the whole time, no matter what I put in for t. And then one last example here. We'll do example 5. Okay. Suppose q of t is 5t cubed. And then on A, I want q of 2t. Replace t with open parentheses. Because again, the expression inside the parentheses is getting harder, okay? And then in those open parentheses, I'm going to put a 2t there. Now, when I cube that out, I get 5 times 2 to the third is 8, t cubed. 2 times 2 is 4, 4 times 2 is 8, right? And then 5 times 8 is 40, and so I get 40t cubed. Let's take a look at B. Suppose I want 2q of t. So I want you to just see the difference between these guys, right? I'm going to put brackets around that q of t. because what it's telling me to do is take q of t and multiply by 2. But q of t is 5t cubed. And then isn't 2 times 5, 10? So the correct answer for B is 10t cubed. And then on C, suppose I want q of t squared. Replace t with open parentheses. In those open parentheses, I'm going to put a t squared there. But remember, I'm cubing that. And when I want to finish, I get 5t raised to the 6. Because when you have a power raised to a power, you're going to multiply these exponents here. And then on D, suppose I want q of t squared. But that's 5t cubed to the second. 5 squared is 25. And so I get 25. 5 squared is 25. T cubed squared is t to the 6. Because 3 times 2 is 6. Okay, that'll do it for this video on functions. And this is for my Math 386 class. 386 is like a preparation for calculus. And so I did 5 examples, 4 parts each, where I evaluated functions for given values. Okay, thank you.